Welcome back, students. In previous lecture video, we already discussed on clearance and clearance volume. There are some idea. Now, today's topic is actually volumetric efficiency. Okay. Now, you have to calculate the volumetric efficiency of an reciprocating compressors. Now, first of all, we have to know that what is volumetric efficiency. Now, volumetric efficiency, the ratio of actual volume of gas taken into the cylinder during suction stroke, because we already know that there are stroke is basically there are mainly four stroke are there. There is a suction, compression, expansion, and exhaust. Now, the volume of air that sucks during the suction stroke to the piston displacement volume, that is basically called volumetric efficiency. Now, volumetric efficiency is designated with this term. Now, that is equals to m dot into v1 divided by p into d. Now, m dot means the mass flow rate of gas, and v1 is the initial volume before compression at the compressors, divided by pd. Pd means piston displacement volume. Okay, pd means piston displacement volume. Now, volumetric efficiency is the ratio between the actual volume of gas taken into the considerations into the cylinder during suction stroke to the piston displacement volume. Now, we already know that piston cylinder assembly clearance volume, that is basically 1 plus C minus C. You have to prove that P2 by P1 to the power 1 by N. Now, volumetric efficiency is 1 plus C minus C into P2 by P1 to the power 1 by N. You have to calculate. Now, volumetric efficiency is also written like that: V1 minus V4 divided by V1 minus V3. So, V1 minus V4 divided by V1 minus V3. Now, V1 minus V4 from PV diagram, you also shown that in the 1, 2, 3, 4 is basically process, which is indicated as arrow. Now, V1 minus V4 is actually effective swept volume, and you know that from the previous lecture video, V1 minus V3 is your swept volume. Okay, swept volume. Now, V1 minus V4 is actually the actual volume of gas taken into the cylinder during suction stroke, that is V1 minus V4, divided by piston displacement volume, that is nothing but swept volume, that is nothing but V1 minus V3. So, it is the ratio between V1 minus V4 divided by V1 minus V3 according to the PV diagram. Now, you know that V1, V2, V3 and V4 according to this. Vs is equal to V1 minus 3, already we have discussed on the previous lecture video. Now, V1 minus V4 divided by Vs. Now, clearance ratio, that is the ratio between, that is designated with capital C term. Now, clearance ratio is the ratio between clearance volume divided by swept volume. Now, clearance volume already some idea in the previous lecture video, that is basically the space occupied within the clearance space. Actually, the volume that is called basically clearance volume. Now, clearance volume is designated with Vc divided by swept volume, that is Vs. Now, Vc by Vs, you know that Vs is nothing but V1 minus V3. Now, clearance ratio, you also write C is equal to Vc divided by V1 minus V3, or Vc by Vs. Now, the question will come in your semester that prove that volumetric efficiency is equal to 1 plus C minus C P2 by P1 to the power 1 by N. The question will be asked in your semesters. Now, when you prove that, so from that expression C is equal to Vc divided by V1 minus V3, from that expression Vc is nothing but V3. You know that V3 is equal to Vc, right? Now, when you write down C is equal to Vc by Vs, you also write down Vc or V3, both are same actually. So, from that expressions, when you prove that, so V1 minus V3 is equal to Vc by C, right, or V3 by C, both are same. Now V1 is equal to V3 by C. C is your clearance. C is the clearance ratio, that is designated with capital C. We already discussed before. Plus V3 in that direction, V3. So V1 is equal to V3, just common, 1 plus C plus 1. Okay. Now we have some idea that what is pressure ratio, compression ratio. Pressure ratio is nothing but is the ratio between the delivery pressure. So delivery pressure by inlet pressure. Okay. Now for the process 3 to 4, you know that process 1 to 2 is your suppose this is your PV diagram, and this is the PV diagram. So 1, 2, 3, 4, in which 1 to 2 is your compression process and 3 to 4 is your expansion process. Now for the expansion process 3 to 4, if you apply the polytropic relationship between 3 and 4, you can write down P3 by P4 is equal to V4 by V3 to the power n, because V3 to the power n is equal to V4 to the power n, because 1 to 2 and 3 to 4 both are actually polytropic. This follows the polytropic process, so obviously satisfy these equations. Now from that expressions you can write down V4 by V3 is equal to P3 by P4. Now P3 by P4 is nothing but P2 by P1, because of P3 and P2 both are constant pressure line, because P3 and P2 is your constant pressure line. So you can write down P3 is equal to P2 and here P4 is equal to P1. So that is nothing but V4 by V3 is equal to Rp to the power 1 by n. Rp is your pressure ratio. Now from that expression you can calculate V4 is equal to V3 into Rp to the power 1 by n. Okay. Now you know that the volumetric efficiency is designated with now is equal to V1 minus V4, that is basically effective sweep volume divided by, or you can say that the actual air sucked during the suction stroke, and divided by V1 minus V3, that is your sweep volume. Now V1 in terms of V1, you already in the previous, so V1 is equal to V3, V1 is equal to V3 divided by 1 plus C by 1. So write down here V1 is equal to V3 into 1 by C plus 1 minus of V4 is equal to V3 into Rp to the power 1 by n. So write down here divided by V1 minus V3. So V1 minus V3. So V1 minus V3. So V1 minus V3 is nothing but Vc by C or V3 by C. So write it here. So V1 minus V3 is your V3 by C. So V3, if you common out here, so V3, so V3 and V3, so both will be cancelled out, V3 and V3. So ultimately the expression was 1 plus C plus 1 minus of Rp to the power 1 by n divided by 1 by C. Now these are algebraic calculations, so C is will be common from that term. So after all, the final expression of the volumetric efficiency will be 1 plus C minus C to the power into Rp to the power 1 by n. So Rp is nothing, this is the pressure ratio, you know that Rp is your pressure ratio, which is ratio between delivery pressure divided by inlet pressure, or P2 by P1 and P3 by P4. Now in terms of Rp you can write down also P2 by P1 to the power 1 by n. So this question will be asked in your semesters, what is the volumetric efficiency, just prove that. Okay. Now from that volumetric efficiency expressions 1 plus C minus C to the power P2 by P1 to the power 1 by n, from that expressions you know that P2 by P1 is basically pressure ratio to the power 1 by n is basically greater than 1. So NB means volumetric efficiency is decreased as the clearance is increases, because of the minus here, so term minus is here, so minus C. So as the C increases, the volumetric efficiency will be decreases. So okay, as because of pressure ratio increases. Okay. Now the mass flow rate from the previous expression, because we know that volumetric efficiency is the mass flow rate into V1 divided by piston displacement. Okay, so piston displacement volume. So from that expression you know that volumetric efficiency 1 plus C minus C into P2 by P1 to the power 1 by N into M1 into V1 P into D. From that expression you can also write down mass flow rate, that is M is equal to PD by V1 into 1 plus C minus C to the power P2 by P1 to the power 1 by N. So these are the mass flow rate expressions. So PD by V1 to the 1 plus C minus C into P2 by P1 to the power 1 by N. Okay, just go through the lecture video, and thank you very much for listening me. Okay, goodbye.